Guys, and welcome back. So in this video we are going to be looking at limit by substitution. Okay, now what do you actually mean by limit by substitution? This is when you're trying to treat limit as though you're looking at polynomial substitution or substitution in function. What it simply means is this: you have the limit of f of s as x tends to a. Now, instead of you going ahead to look for limits using other methods that we are going to see later on, you just go back to your old traditional way of looking for evaluating functions, which means anywhere you see x, you just put in the value of a. So it's as though you're evaluating the function at a instead of looking for a limit of the function as x tends to a. So this is what you call limit by substitution. You just go ahead and substitute values. We have a couple of examples based on that. The first example we want to look for a limit of 2x minus 4 as x tends to 1. So all we need to do is to substitute x as 1 into that function, and if we substitute x as 1 here, we're going to get 2 times of 1 minus 4, which gives us minus 2, and that's the limit. So in this case we say the limit exists because we are actually getting a value, so the limit exists. Okay, another situation we have is if we have a question like this: limit of x raised to the power of 4 plus 1 all square as x tends to minus 2. So here we are going to substitute minus 2 here. Substituting minus 2, you have minus 2 raised to the power of 4. Minus 2 raised to the power of 4 will give you 16. 16 plus 1 will give you 17, and that becomes 17 raised to the power of 2, and 17 raised to the power of 2 will give us 289. So here also the limit exists. Let's see another one. Here we have the limit of x minus 3 all over x squared plus 1 as x tends to 2. Substitute x as 2, you have 2 minus 3 all over 2 squared plus 1. You can see how simple these things are. Okay, and that will give you minus 1 over 5, which you can also express as minus 0.5. So here also the limit exists because we are getting a number. Okay, all we are doing is to substitute. Let's take our substitution on this. By now you've gotten the vibe. So put x as minus 4 there. You have minus 4 plus 4 over minus 4 plus 1. That will give us 0 over minus 3. 0 divided by any number, it's actually equal to 0, except 0 divided by 0, which we are going to talk about later on. But here we are getting a value of 0. 0 is a number, which means the limit still exists. And finally we have this x squared all over x squared minus 9 as x tends to 3. So if you 3 there, you have 3 squared all over that, and that will give you 9 over 0. Now a number, any number except 0 divided by 0 is always said to be undefined. So it could be minus infinity or it can be infinity. Okay, so since you're saying a positive number divided by 0 is going to be infinity, but if it were to be a negative number, let's say negative 3 divided by 0, then this would have given us minus infinity. But it doesn't matter if it's infinity or minus infinity, both cases we know that the limit does not exist. Okay, so this is, guys, for limit by substitution. Now this is one place that people do fall victim when they see that you're getting something over 0. Instead of them to say the limit does not exist, they would try to now use them for the L'Hopital rules we are going to look at, just because they've studied L'Hopital rule and they just try to keep on using it, and that's wrong. So I'm just trying to give you heads up based on that. Okay, so we are going to end this video here, and in the next video we are going to be looking at when we have some other cases, how do we use other kinds of limit by factorization, by rationalization, and also by L'Hopital's rules. So we are going to bundle all these three and use them to solve different kinds of questions. Okay, so I'm gonna see you guys in the next video. Until then, make sure you subscribe to this channel. Go ahead and share the videos among your friends and invite them. Click on the like on the bell button so that you get notified whenever I upload new videos. So I'll see you guys in the next video. Bye bye.